So today we are going to be looking at how to graph the sine and cosine curves. So the sine and cosine curves can be graphed on an XY axis, and that's what we're going to be taking a look at. So looking at this first problem here, we're trying to graph y equals sine x. So what we're going to have to do is we have to come up with some points in order to graph something. So I'm going to make a unit circle here. And we're going to get some points. So the easiest points we have that we can figure out are going to be when x is quadrantal, when our angle is quadrantal. So this would be a quadrantal point, this is quadrantal right there. So what's this angle right here in radians if I don't move at all? 0. What's the next one I come to in radians? And the next one? And finally, good. Okay, now we're going to think of the points there. So right here at 0, this point is over 1, up and down 0. This point is over 0, up 1. What's this point right here? This point right here? Good. Okay, so now we're going to find y. Y is the sine at these angles. So at 0 radians, what's the sine going to be? Is it 1 or 0? What's the sine of 0? 0.
Right, that's x equals 0.
That's the angle. X is the angle. So when the angle is 0, what is the sine? So when I have a point, the sine is the y value. Okay, at pi over 2, what is the sine going to be? 1. At pi, what's the sine of pi? 0. What's the sine of 3 pi over 2? And what's the sine of 2 pi? These are called the 5 key points for sine. We're now going to plot these points on an xy axis. So when x is 0, y is 0. There's the point 0, 0. This is the x-axis, the y-axis. When x is pi over 2, y is 1. When x is pi, y is 0. When x is 3 pi over 2, y is negative 1. And when x is 2 pi, y is 0. I'm now going to connect these dots. We're not going to make this pointy. It's actually very gradual. So we're going to come up gradually, come down gradually, and come back up gradually. This is what we call one period. The reason it's called one period is that's how long it takes in the x direction for it to start repeating itself. For it to go 0, 1, 0, negative 1, 0. It takes 2 pi for that to happen. Now, it also continues on forever. So what about at negative pi over 2? At negative pi over 2, what is the sign right there? Negative 1. John, turn that off. At negative pi, what is the sign? What about at negative 3 pi over 2? What's the sign going to be? Good. And at negative 2 pi, it's going to be 0. So you can see how this curve continues on forever. I want you to know how to graph this on the calculator too. Everybody go into your calculator, turn it on. Go to y equals. And I want you to put in our function, which is sine x. So type in sine, and then right here, guys, next to alpha is the x key. Now, you need to check your mode first of all. You can actually be in degrees or radians and it will work, but how are we setting this up? In what mode? So go ahead and change your mode to radians. So make sure you have radians under mode. And now what I want everybody to do is a zoom. What are we working on right now? Trig. So we're going to do a zoom trig, which is number 7. And the calculator will graph for us. Now, I also want you to be able to look for the 5 key points under table. And if you look at your table right now, it's probably not going to look right. These are the 5 key points that we came up with. So to fix it, guys, go to second window to get to your table set. Second window. Our table is starting at 0. Delta means change. So what's the change in our table for the x's? How much are we going up by every time? So we're going to make our delta table be pi divided by 2. And now go back to your table. Do second graph to get to your table. And do you see now how the points work out right? 0, 1, 0, -1. Yeah, Vlad.
How do I find that?
You go to your table set. Do you have it going 0 and then pi over 2 for delta table? Delta table has to be pi divided by 2. Then you have to quit by doing second mode to quit. And then you go back to your table, which is second graph. And there you can see the table of values. Did you guys get it? Raise your hand. Got it? Okay. Does anybody need help? Okay, what do you have going on, Vlad?
I got a syntax error when I tried going to the table.
Okay, I want you to do a second mode to quit, and I want you to clear everything on your screen. And now go back to table, second graph to table. Do you still get it?
Yeah.
Syntax. Go back to your table setup. Make sure you have this as 0, and this should be pi, which is, or just put in 3.14 divided by 2. See if that works. Did that work? The only thing is now it's going to be a little bit off. Can you
I still get it.
Okay, bring it here and let me look at it. Carmen, what's going on with yours?
Oh, I was just asking a question.
Okay, what's your question?
So would you need to do that every single
No.
time?
The reason we don't have to do that every single time, we got something in here you don't need. Okay, you're good now. Just do your pi over 2. It's because there was something way down below that was not really an equation. Okay, you're good. Okay, guys. So no, you will not have to. We've done this. It's all set up right. It should work. Krish? Great question. He's talking about right here. Why is it not showing a 0 like it should? Well, this is -2 times 10 to the -13. What is -2 times 10 to the -13, really? It's -0.0000, all these zeros and then a 2. So basically, the calculator's trying to be too exact. That is 0. Anytime you see something like that, it's 0. All right, guys.
My guess is that probably rounded high a little.
Correct.
And that's why it's getting that.
That could happen too. Okay, so what I want you to do now is let's change our mode. Let me show you something with your mode. Let's say that you prefer to think in degrees. If I changed my mode to degrees, now you may not want to do this because we typically use radians, but if I change my mode to degrees and now I look at my table, can you see how it's not the way it should look now? But that's because if I'm thinking of this in degrees, how many degrees am I going up by every time? What's pi over 2 in degrees? 90. So I would now have to change that to 90 degrees and see how now it's back to normal again. But we're going to go ahead, we're going to use radians. So I'm going to go back to radians and I'm going to keep this as pi over 2. But just understanding, A lot of times people will be taking a quiz or something and they're like, my calculator's not working. Well, it's because you have some things in radians, some things in degrees. You got to be consistent. Okay? Let's find the five key points now for cosine. So we're going to use one period, which is from 0 to 2 pi, and we go up by pi over 2. We're going to use those quadrantals. So at 0, what's the cosine of 0? 1. What's the cosine of pi over 2? At pi, at 3 pi over 2, and at 2 pi, 1. Okay, so these are called the 5 key points for cosine. It helps us to understand what one period of the graph looks like. So at 0, we're at 1. Pi over 2, we're at 0. Pi, we're at -1. 0, 1. Now, if I go backwards, what about at negative pi over 2? What's the answer for negative pi over 2? What's the cosine for negative pi over 2, guys? 0. Can you see how this pattern continues on forever? So my next point would be at -1. For negative pi, the cosine of negative pi is -1. Negative 3 pi over 2 is going to be 0. And negative 2 pi is going to be 1. Connect the dots. Make it look like a curve. All right, so there we go. Let's graph it on our calculator now. Go to y equals. Check it out. Put in cosine x. You don't even have to do a zoom 7 anymore. I'm going to go ahead just in case, but if it's not looking right, do a zoom 7. But a lot of times you can just hit graph now after you've done the zoom 7. And there we go. So guys, one period of this graph is starting here and ending here. Do you see how that's one period? What is the period here? How far in the x direction did it take us to hit those 5 key points? What's that distance, guys? Not pi. Look at it here. How long did it take us to reach 1, 0, -1, 0, 1? How far? 2 pi. Okay, so state the domain. The domain is going to be -infinity to infinity. Just a little side note, if you're in college, they might say this domain is x is in the element of real numbers. Sometimes they write it like that. The range means our low point to our high point. What's our lowest point for y? -1, 1. Inequality form would be -1 less than or equal to y less than or equal to 1. I'm just showing you both ways. We're going to be using the first way I put it, but just understanding it can be written that way. The amplitude. Guys, there's a line that goes down the middle here that's called either the sinusoidal axis, and it can also be called the midline. The distance from that middle line to a high point or middle line to a low point, that's what we call the amplitude. So what's the amplitude on both of these? 1. And the period is how long it takes from here to here. How long does it take to reach all 5 of those key points? How far is that? 2 pi. All right. Down here at the bottom, they're just repeating everything again. Okay, so we're not going to go through that. Turn over to the next page. So here they're telling us the amplitude. The amplitude and the period of the graphs of y equals a sine bx and y equals a cosine bx, where a and b are non-zero real numbers, are as follows. The amplitude is always going to be the absolute value of a, and the period is going to be 2 pi over the absolute value of b. Circle those. They're going to come in handy later when they ask you about that. So we're now going to look at y equals 3 sine x. We're going to graph this on the graphing calculator, and we're going to compare it to y equals sine x. Go to your calculator. Go to y equals, into y1, put in sine x. Into y2, put in 3 sine x. What do you guys predict is going to happen when we put a 3 in front of there? What do you think it's going to be? All right, Chris is going like this. What's that mean? Guys, what happened in the past when we would put a number out in front or multiply through by a number? It's a vertical what? So we're expecting to have a vertical stretch by 3. Go ahead and push graph. Here's the regular sine curve. Here's the new one. Does it look the way you thought it would look? Just a vertical stretch by 3? All right, here's what I want you to do. Let's write out these 5 key points. So normally our 5 key points go 0, pi over 2, pi, 3 pi over 2, and 2 pi. How do the 5 key points for sine normally go? What are these points usually? 0, then what? Do you remember, guys? What's the sine of pi over 2? So it goes 0, 1, then what? Keep going. But how are they going to go now that we have that 3 out in front? And let's check that. Go to your table. Second graph to go to your table. In red, here are the 5 key points. 0, 3, 0, -3, 0. So we can use our graphing calculator to check those 5 key points. All right, let's do a more difficult problem. Now we're going to try to do this. Y equals 4 cosine of 2x. Good job. So normally our key points are going to go 0, pi over 2, pi, 3 pi over 2, 2 pi. For cosine, how do those y values go for cosine? What's the cosine of 0? Pi over 2. 0. Next one. Keep going. Good. This is 1 period. So normally 1 period is from 0 to 2 pi, right? Let's look here first. What is this 4 going to do? Stretch it vertically, right? So what are our new y values going to be? Great. So these are going to be our new y values right here. These are the y values we're going to use. Okay? Now, what happens when we replace an x with 2x? What's that going to do? Horizontal shrink by a factor of what? 1/2. So I'm going to have to take all these x's and multiply them by 1/2. So this is going to be multiplied by 1/2. What's 1/2 of pi over 2? Pi over, what's 1/2 of pi? What's 1/2 of 3 pi over 2? And what's 1/2 of 2 pi? So now what is the period going to be? How long before it starts repeating that pattern? Not 2 pi like usual. Now it's what? Pi, right? Look at the formula up here, guys. It's 2 pi over b. What is 2 pi divided by 2? Pi, right? All right, what's the amplitude going to be? It says it should just be the a value. So what's our a value here? 4. So the amplitude is going to be 4. Let's check it on the graphing calculator. Clear everything out. Go into y equals and put in 4 cosine 2x. Do a zoom 7. That's always a good way to make sure you're on the right screen. There's the way it looks. Let's look at our table of values. Now, I want you to think about this table and how it's not really going to look right. Go second graph to table. We thought the points should go 4, 0, -4, 0, and they're not going that way. Why is that? How much are these increasing by? What's 1.57 in radians? Pi over 2. That's not what we're increasing by. What are we increasing by? Pi over 4. So I've got to go to my table setup and say, no longer are we increasing by just pi over 2. We're increasing by pi over 4. So we're going to have to change this delta table to pi divided by 4. And now when we look at the graph, now we can see it. 4, 0, -4, 0, 4. Makes sense? Okay. All right, guys. I'm going to do 2 and 4 with you, and then I'm going to ask you to go back and try 1 and 3 on your own. So let's look at number 2. Not using the graphing calculator. Let's think of what our 5 key points should normally be for sine. They go 0, pi over 2, pi, 3 pi over 2, 2 pi. Do you guys remember the 5 key points?
0, 1, 0, 1, 0.
Great. Do we have any changes to that? Do we have a vertical stretch or anything else? Vertical stretch by a factor of what? 3. So I'm going to multiply these by 3. That's going to be my new g of x, which means y. That's going to be my new y value. Now, this is kind of strange, but we have a pi in front of that x. When we have a pi in front of that x, then what is going to happen?
It's going to cancel out.
Yeah, because like back here, I had to multiply by 1/2. What am I going to have to multiply by now? 1 over pi. So I'm going to have to do 0 times 1 over pi. That's still 0. What is pi over 2 times 1 over pi? 1/2. What is pi times 1 over pi? 1. Now you should be able to see the pattern. How much are we going up by every time? 1/2. So if I go up by 1/2 with the 1, what am I going to get? 3/2. And go up by another 1/2, what am I going to get? 2. All right, so what is the period now going to be? What is it, guys, before we start repeating? How far is it from 0 to 2? 2. The period's going to be 2. I can also find that period by doing 2 pi divided by, what's the b value? What's in front of the x? What does that reduce to? 2. That's the period. The amplitude is that a value. What's the amplitude going to be? 3. So we're now going to graph this, plot the points. So I'm going to have 0, 0. I'm going to make these go by 1/2. At 1/2, I'm going to have 3. At 1, we're at 0. 1.5, we're going to be at -3. And at 2, we're going to be at 0. This would be one period, guys. That's one period. See how it's going through the 5 key points? It's here, up, here, down, back on the axis. That's what we mean by one period. You should be able to look at this. If I tell you this is 1 and this is 2 and this is 0, you should be able to see that that period is 2. Could you graph it backwards? Like, am I going to go back up here or am I going to go down here? Down. So we're going to go down 3 here. And then I would go on the axis and then up and then on. Okay? How many periods did I just graph? 2 periods, right? That would be 2 periods. Okay, guys, let's do number 4 together now. Let's go in a different order. Let's find the period first. Period first. So we're going to have to do 2 pi divided by, what's the b value? So what's 2 pi divided by 3 pi? 2/3. So we should start at 0 and end at 2/3 if we do this correctly. That's what that tells me. The amplitude should be what? 1/2. All right, so normally we go 0, pi over 2, pi, 3 pi over 2, 2 pi. What are the cosine values normally? Look here, cosine, does it go 0, 1 or 1, 0? Goes 1, 0, -1, 0, 1. What does the 1/2 do? Do I multiply the x's by a half or the y's by a half? The y's get multiplied by 1/2. Now, what am I going to do to the x's? What's in front of there? What's in front of that x?
3 pi.
3 pi. So all of these are going to have to get multiplied by 1 over 3 pi. So what's 0 times 1 over 3 pi? Pi over 2 times 1 over 3 pi. Pi's cancel. What do I get? 1/6, right. What's pi times 1 over 3 pi? 1/3. Look at this pattern, guys. 0, 1/6. What's 1/3 with a denominator of 6? 2/6. So what's the next one going to be? 3/6, which is what? So this is 3/6. My next one's 4/6, which is what? 2/3. Did that work out correctly? Is that period 2/3? Good. Okay, so I'm going to make this, and I can adjust my axes however I need. Let's see. I'm going to just make this 0. This is 1/6. I'm going to call this 1/3. I'm going to call that's going to be a half, and this I'm going to make this 2/3. And I'm just going to go ahead and make this be 1 and this be 2. Just as easier to see if you kind of zoom in on it a little bit. All right, so at 0, I'm going to be at a half. Oops, I didn't mean to put that there. At 1/6, I'm going to be at 0. At 1/3, I'm going to be at -1/2. Here I'm at 0, and here I'm at a half again. These are kind of hard to graph. I'm just going to graph one period. So if you saw this much, you should be able to tell that the period is going to be 2/3, because that's how long it takes for us to make that one cycle, is what that's called. So from 0 to 2/3, that's going to be how long it takes to start repeating. All right, how do you guys feel confidence-wise on a scale of 1 to 5? 1 being you're very confused. Oh, lots of 4s and 5s. Very good. Okay, guys, so let's see if you guys can now just graph 1 and 3. You just have to do one period of it. Just one period of it. Okay? And I'm going to turn this off, and then I'm going to roll the dice, and we're going to figure out whose paper I'm going to show up here. But I'm going to turn this off for a second, and you guys, you can work with a partner if you want as well. Those of you watching the video, you should try this on your own.